All right, let's get right into it. We're going to talk about one of the first and biggest architectural decisions you'll make when you're building anything that talks over a network, TCP or UDP. Think of this as a practical guide from one engineer to another. We've all been there, and trust me, this choice can make or break your application.
So here's the fundamental question you have to answer. What's more important, getting every single piece of data to its destination perfectly, or getting it there as fast as possible? This isn't just some minor technical detail. No, this is a choice that will fundamentally shape your user's entire experience. Let's break down what that really means.
Okay, first up is TCP, the Transmission Control Protocol. This is your go-to, your default, your old faithful. When data integrity is absolutely positively non-negotiable, you pick TCP. It's the reliable workhorse that powers most of the internet as you know it, and we're about to see exactly how it earns that reputation.
And this phone call analogy? It's pretty much perfect. It gets right to the heart of why TCP is called a connection-oriented protocol. Before a single byte of your actual data is sent, a dedicated, stable channel is set up between the two ends. You don't just start shouting into the void, you make sure someone is on the other end, ready to listen.
That phone call setup has a formal name, the three-way handshake. And it's more than just a simple hello. It's this beautiful little dance of messages, SYN, SYNAC, and ACK, that confirms both the client and the server are not only present, but they're also ready and have allocated resources for the conversation. This handshake is the absolute bedrock of TCP's reliability.
So, what does that little dance actually get you? Well, it gets you guarantees. Lots of them. TCP makes sure that every single packet is acknowledged. If one gets lost in the mail, don't worry, it's sent again. It also puts a sequence number on every packet, so they can be put back together in the right order. It's like a built-in safety net that prevents your data from ever getting corrupted.
But reliability isn't just about not losing data. It's also about managing the flow of that data. You can't just blast data at a receiver and hope for the best. And this right here is where TCP's real elegance shines through. It's got this amazing ability to control the flow.
TCP uses something called flow control to make sure the sender doesn't completely overwhelm the receiver. It's a dynamic feedback loop. The receiver is constantly telling the sender, hey, I've got this much buffer space left, which ensures the data transfer is smooth and efficient, not a chaotic mess. And the clever mechanism behind all this is the sliding window. Here's how it works. The receiver advertises its receive window, basically how much data it can handle at once. The sender can only send up to that amount and then has to wait for an OK. As the receiver processes data, that window slides open, giving the sender permission to send more. It's brilliant, a continuous adaptive flow.
All right, let's totally shift gears. Let's look at the other side of the coin. What if your top priority isn't perfect, bulletproof reliability? What if all you care about is raw, unadulterated speed? Well, that's where our friend UDP, the User Datagram Protocol, comes into the picture.
UDP is the polar opposite of TCP. It's connectionless, and this postcard analogy is spot on. There's no handshake, no acknowledgements, no flow control, nothing. You just fire off the data and hope it gets there. It's a fire and forget approach. You're trading all that reliability for the absolute minimum amount of delay. And this slide right here, this gets to the very heart of the difference. TCP is like a car with smart cruise control. It's always listening, always adjusting its speed based on traffic and conditions. UDP is like flooring the gas pedal and just hoping for the best. It sends data at a constant rate no matter what. That's why it's so fast, but it's also why it can be so risky. And here's the visual proof of why UDP is so much faster. Just look at the header overhead. A UDP header is a super lean 8 bytes. A TCP header, on the other hand, starts at 20 bytes and can be as big as 60. All that extra baggage in the TCP header? That's the cost of doing business. That's where all the info for sequencing, acknowledgements, and flow control lives. Less baggage means less processing and faster delivery. So, there we have it. We've got the reliable but methodical TCP and the fast but risky UDP. How in the world do you, as the architect, choose between them? Well, it all comes down to one thing: really understanding your application's needs.
Consider this table your cheat sheet. For something like a file transfer or loading a web page, every single bit has to be perfect, so you use TCP. No question.
But for online gaming or a video call, a tiny dropped packet here and there is way better than a huge lag spike that ruins the experience. For those, UDP is the clear winner. You have to ask yourself, what's more damaging to my user's experience, a tiny bit of data loss or a noticeable delay?
Okay, so we've covered the theory, we've talked about the trade-offs. Now let's bring it back to your keyboard. How does this huge architectural decision actually look in your code? You're probably going to be surprised by how simple it is.
Look at this slide. Seriously, after all this discussion about complex protocols, handshakes, and sliding windows, it all comes down to a single parameter when you create a socket. The only difference you see between the TCP and UDP client code is that very last argument.
And that's it. Sock stream for TCP, sock dgram for UDP. You're basically just telling the operating system which philosophy you want to follow, the reliable phone call or the speedy postcard, and it handles all the nitty-gritty details for you. Your job is to make the right high-level choice.
So as we wrap this up, let's boil it all down to the one key takeaway that you can bring to your next big project.
Please remember this: there is no best protocol. There is only the right protocol for your specific job. If you understand the trade-offs and you know what your application truly needs, the choice becomes crystal clear.
And as you go off and make those choices, I'll leave you with a little food for thought. What happens when you need both? What if you want the speed of UDP, but with some of the reliability of TCP? That question is exactly what's driving the next generation of protocols, like QUIC. The world of networking never stands still, and our job is to keep learning with it. Now, go build something amazing.